Welcome everybody to today's GRDC sponsored webinar on managing sorghum injury when using metalachlor herbicides. You're listening to Mark Congreve from ICANN, and I'm going to be presenting this webinar. For those that are familiar with this webinar series, we generally run for about a 20 to 30 minute presentation. This webinar is being recorded and we will upload it to the GRDC YouTube site after the end of this webinar series. This is the second one following on from one that we did last week on feathertop rhodes grass. We'll be back again in probably May to do a couple more webinars to continue on this series. What I wanted to talk about today was managing weed control in sorghum, particularly using metalachlor-based herbicides, and how we avoid herbicide injury to sorghum. Anecdotal reports that have come back to us are indicating that growers do see damage from time to time, and it can be of quite concern. So what we want to talk about today is the factors that dictate whether this is going to occur and how we're going to manage it. So to kick off, really just to set the scene, why do we want to control weeds in sorghum? Obviously there's a big yield penalty to having weed establishment issues when we're trying to get the sorghum established, and we don't want to set the crop back, which can potentially result in yield penalties down the track. From a broadleaf point of view, we can attack the broadleaf weeds with pre-emergent options, or we do have some very reliable and very useful post-emergent options available to us. In particular, fluroxypyr-based herbicides, plus or minus one of the triazines, such as atrazine or terbuthyrazine, control most of our key range of broadleaf weeds from a post-emergent perspective. But when we're looking at grasses, we really don't have too many useful post-emergent options apart from possibly inter-row cultivation. And so we're really heavily relying on pre-emergent control to manage our grass weeds in sorghum. And mostly we're using some form of metalachlor-based herbicide, and we may or may not add atrazine or terbuthyrazine, one of the triazines, to improve some of the grass control, but particularly to add broadleaf control to that mix as pre-emergent. But the metalachlor herbicides aren't completely safe to grass crops in general and sorghum specifically. So we can, under some circumstances, end up with some injury, and that's what we want to really focus on today, is how we can manage that or prevent that in the first place. So if you look at the selectivity of metalachlor herbicides to grass crops, what you notice is the way the label's constructed, there's great variability across different species. So this is just an excerpt from the equivalent to the dual gold label, the 960 gram S-metolachlor product. If you look at the label, you can apply up to 250 mils per hectare in wheat, 500 in barley and oats, a litre in cotton, 2 litres in sorghum when we're using Concep II treated seed, and 2 litres in maize or summer broadleaf crops. So what you can see there is there's a great range in difference in selectivity of the amount of herbicide that each of those different crops can tolerate. Some, such as wheat, not being able to tolerate much, others, such as maize, being the most tolerant of the species that we're dealing with. What we want to really focus on today is sorghum, and in particular the area that I've highlighted here, and the maximum use rate, 2 litres per hectare of the 960 metalachlor in combination with Concep II treated seed. And I'll talk a bit about why we need the Concep treated seed and some of the limitations that arise from that. So just wait for the slide to come up. But I guess the first thing is, what should we be looking for when we're talking about metalachlor damage to sorghum? So I've just included some pictures, hopefully they've come up on your screen by now, of showing what metalachlor damage looks like in sorghum when it does occur. So on the left-hand side of the page, a couple of different age seedlings there that are showing minor levels of damage to metalachlor herbicide. So you can see this crinkling of the leaf, and usually if we've got damage at that sort of level, we see this temporary injury. It may hang around, it may stay in there, but generally those crops are probably going to grow out of any sort of damage at that stage. If we look at the right-hand side, probably some more severe situations of injury where we're starting to get significant twisting and of the main shoot and some severe root pruning. If we look up in this picture in the top right-hand corner, we're starting to get plants which are probably going to struggle to survive in that situation. And in a worst-case scenario, we actually can prevent the seedling emerging in the first place and actually have misses in the crop row. So we do see everything from no injury to potentially high levels of injury. So again, I'll focus today on what dictates what happens and how that occurs. So what I want to focus on today is a number of different topics. So I'll talk a little bit about formulation and use rate. I'll talk about where the herbicide locates within the soil, dictated by solubility, soil type and rainfall. So we can talk a little bit about that. We'll talk about how the sorghum plant has to be able to metabolize the herbicide that it's coming in contact with. Then I'll move into what we need to do with regard to using Concep II seed safeners on the seed, varietal impacts, and then finish up a little bit with application of the herbicide and how that can influence selectivity and planter setup. So that's the key issues I want to cover off on. So the first thing that we need to quickly touch base on is the actual metalachlor formulation. So there are different formulations available in Australia, and each of those formulations contains two isomers of metalachlor, the S isomer and the R isomer. So as you can see from this graph, the S isomer gram for gram is much more active than the R isomer. So the R isomer still has some weed control activity, but the S is much more powerful in delivering gram for gram performance in the field. So why is that important? There's basically three different formulations commercially available in Australia. The original metalachlor-based formulations were a 720 gram formulation, and it contained both the R and the S isomer in a 1-to-1 ratio. So dictated by this graphic that I've developed here on the left-hand side of the page. So if we had a litre of herbicide, we would have 360 grams of the R metalachlor and 360 grams of the S metalachlor in that litre of product. Formulations evolved, and there are also 960 gram per litre metalachlor formulations available. So these just have a higher total loading of metalachlor, still in the 1-to-1 ratio. So in this situation per litre, we've got 480 grams of each of the isomers in there. And then we also have 960 gram per litre what are marketed as S-metolachlor formulations. Now the S-metolachlor formulations don't contain 100% S-metolachlor. They're approximately 88% S and still have about 12% R in the formulation. And you can see there that how that adjusts to the concentration of each of those herbicides. But the important part is this equivalence ratio down the bottom. So if we are using a S-metolachlor formulation, for example, dual gold, at a maximum label rate of 2 litres per hectare, that provides equivalent weed control and equivalent crop safety to 3 litres per hectare of the 960 gram metalachlor or 4 litres of the 720 gram metalachlor. The point of focusing on that is if we've had growers out there who have been using a 720 gram per litre metalachlor formulation at 4 litres per hectare as according to label, and they were to switch to one of the newer 960 gram per litre S-metolachlors and still apply it at 4 litres per hectare, there's obviously some severe potential for crop injury in that situation. So we really need to understand which formulation we're dealing with. So the next point to focus on is the solubility and rainfall interaction with metalachlor. So metalachlor herbicide is moderately to highly mobile. So what does that mean? It means it's going to potentially move down through the profile with significant rainfall events. And it's also, because of the high solubility, going to be very available to the seedling to be able to take up, in particular under moist conditions. So under wet or moist conditions, the plant is certainly going to have to deal with considerable quantity of herbicide. Soil type will also have an impact. So if we've got heavier soil types, we're going to get more herbicide bound onto the soil. If we're in lighter soils, we're going to have less binding and therefore more herbicide available in the soil moisture. So our lowest scenario lowest risk of damage is going to be in a situation where we have heavy soils, we have no rainfall at all, or maybe just a light rainfall to wet the soil surface and incorporate the herbicide at that level. So under those scenarios, it's unlikely we're going to see too much crop injury. The highest risk of damage is going to come from a combination of light soils, heavy rainfall, particularly between that planting and emergence, and particularly if waterlogging eventuates as well. And can be rainfall or it can be irrigation, either flood irrigation or overhead irrigation. If we're wetting right down to the profile, that's going to be the most likely scenario to start seeing crop injury effect. So I sort of mentioned that the herbicide is likely to come in contact with the seedling. So the seedling needs to be able to metabolize that herbicide, because it's certainly going to take it up as it's taking up moisture out of the soil. So it's got to be able to metabolize that herbicide. By that I mean break down that herbicide before that herbicide can show crop effect. So what's going to influence that? Well, one of the big influencing factors is additional stresses that are on the seedling that reduce the plant's metabolism. So anything that's preventing rapid growth, it's going to mean that the metabolism is going to be slower, and that's going to potentially increase the phytotoxic effects that we're going to see. So waterlogging is a big one. High rainfall situations, waterlogging is very often associated with observations of increased metalachlor injury. Soil temperature, from a establishment of sorghum point of view, we really want to see 16 degrees Celsius at the planting depth, and preferably a rising profile to get good establishment of sorghum. Once we're getting temperatures that are cooler than that, it's going to take a long time for that crop to emerge. The metabolism is going to be much slower at those cooler temperatures, and it's going to have more challenge to be able to break down any herbicide that it's come in contact with. We obviously want good quality seed with high vigour. If we don't have that, again, that seedling is going to have more difficulty managing the herbicide that's needing to break down. Other stress factors such as insects, diseases, poor nutrition, any of those factors can also reduce the ability of the plant to metabolise the herbicide. So we're really looking for excellent agronomy to be able to break down the herbicide as fast as we possibly can within the seedling. What we also can do with sorghum is that we can add Concep II, or we recommend to add Concep II to the sorghum seed before planting. So what does Concep II do? Basically, it just increases the seedling's metabolism, and by doing that, increases the speed that it can break down the herbicide that has been taken up from the soil moisture. Does that by inducing GST. Probably don't need to go into the science of how it does it, but it just basically speeds up the metabolism of the plant. The important point that I want to make is that it doesn't provide 100% protection. All it does is speeds up the whole process, so the plant still needs to be metabolizing for the Concep II to have a incremental benefit. And if I look at the graph that I've got on the page down here, so this is a trial done a few years ago now where we had dual gold at a range of different rates. So the first thing you can notice is that as you increase from half a litre to 1 litre to 2 litres of dual, the biomass reduction as measured in this trial increased as we go across the different application rates. That's probably to be expected as the crop's dealing with more herbicide concentration. And then if you look at the black bars were lines of buster in this case that didn't have any concept on the seed, compared to the blue being the buster that had concept treatment. And you can see there that the addition of concept has reduced the crop injury that was observed in this trial. Hasn't eliminated it, but it has substantially reduced it in all those situations. and that's basically what the seed safener does. It reduces it to hopefully an acceptable level, won't eliminate it completely. So if you look at variety, a lot of questions come around, are different varieties of sorghum, excuse me, more tolerant to Concep than others? So this is a trial done in combination between Pacific Seeds and Syngenta, looking at a range of different varieties that were planted into this trial. And they measured the emergence as reference to no herbicide treatment. And you can see there's a little difference between the different varieties there. Some are slightly ahead, some are slightly below, but basically for all intensive purposes, there's no varietal difference in the emergence, and that was either at the 1 litre rate of dual gold or 2 litre that was included in this trial. And there was an assessment of vigour taken, again comparing to no herbicide applied, and again very little difference between variety, or effectively no difference between variety, but all the vigour lines are probably slightly behind the same lines where there wasn't any herbicide applied. Again, that's just reflective of the fact that the crop does have to actually break down this herbicide as it's dealing with it in that establishment phase. So it's not surprising that there is a slight impact there on vigour, but obviously we're using it for weed control purposes. A more recent data set, this trial is currently in the ground at the moment, so this is some work that NGA are doing at Hermitage Research Station, planted just before Christmas. So 14 sorghum varieties in this trial, looking at a lot of the newer sorghum varieties which have recently been launched into the marketplace. 4 different treatments, so there was no herbicide applied at all. There was dual gold applied at 1 litre 26 days prior to planting and another litre just after planting to look at split applications. There was just the 1 litre applied 1 day after application and 2 litres applied 1 day after application. So we had the various different ways the label is designed reflected in that trial. Planted into good moisture, and then you can see the rainfall soon after planting, so 16 mils at 3 days, another 17 mils at 6 days, another 13 mils at 7 days. So reasonably useful wetting of the soil profile. Across all of that at emergence, there was very little evidence of herbicide effect in damage. If you really looked hard in the 2 litre rate of dual gold, you could find the odd plant that was showing some of those herbicide symptoms that I showed in one of the earlier slides today, but it was probably less than about 2% of plants were showing any injury at all. Emergence counts were taken, and there was no difference between any of the varieties or any of the herbicide treatments in terms of emergence. And then we come back and ran the green seeker over the plot to look at total biomass there, and basically there was no difference between varieties or treatments. There was one variety that was just ticking over the significance level from the dual gold at the 2 litre per hectare rate, but practically no difference between any of the varieties in that particular trial, and that trial continues as we speak. So to move on from application rate and variety to a little bit about application timing and incorporation. So if you look at the dual label, it has a recommendation to incorporate within 10 days of application of that herbicide. So why is that there? That's there because if we leave the herbicide out on the soil surface under high intensity UV light and no incorporation mechanically or by rainfall, there is some potential for that herbicide to start to be lost by either UV light breakdown or low level volatility loss off the soil surface. So ideally, we want to see it into the soil, incorporated and activated within that sort of 10-day window. What can be done to achieve that? We can mechanically incorporate it. If we're going to do that, and let's assume we're most likely probably operating in a reduced or zero-till farming system where most of our weed seeds are going to be near the soil surface, we only want to incorporate the herbicide to a shallow depth to try to keep it near where those weed seeds are germinating. So shallow incorporation is all we're looking to achieve at that point in time. Best case scenario, if we're using moisture to incorporate it, would be a light rainfall event that's going to wet the soil again down to that maybe 3 to 4 centimetre depth. If we have the option of overhead irrigation and we can dial up how much water we're going to apply, again, we're only wanting to incorporate very shallow, take the moisture down to that shallow depth. We don't want to be applying inches of rainfall under an irrigation scenario to move the herbicide down to where the crop is or even below. So we're not irrigating the crop for a watering for the crop's point of view. We're just trying to incorporate the herbicide into the soil surface. And because of those limitations, we don't want to be moving the herbicide too deeply and we just want to be incorporating in the soil surface. Flood irrigation really isn't a good process for incorporating herbicides such as dual gold. The solubility we'll see, in a flood situation, we'll see a higher concentration down towards the tail drain of the paddock and a lower herbicide concentration up towards the head ditch. We'll also get herbicide moving too deep in the profile as we're completely wetting the profile, and we're also probably going to struggle to move the herbicide up to the top of the beds adequately to give weed control in that situation. So flood irrigation is really not good for trying to manage some of this incorporation. Providing we can incorporate the herbicide adequately within that window, as I mentioned before, that 10 days, at those sorghum use rates of 1 litre to 2 litres of the S-metolachlor type formulation, we probably should expect about 6 to 10 weeks residual, particularly under moist conditions where we're continuing to see the herbicide break down. That can be a challenge in sorghum in a long season crop like sorghum or maize for that matter, whereby the herbicide may not last long enough to get right through to harvest, particularly, as I mentioned, under conditions conducive to rapid breakdown of the herbicide. But we can't apply more than that because we start running into crop injury issues. So just a couple of bullet points to focus on planter setup. So if we've got my little graphic here of my planter coming along and removing the treated soil out of so we've applied our herbicide, we're then coming in and planting, and we're throwing our treated soil out into the interrow, potentially we've got this situation where we've got a low concentration of herbicide down the planting line. So that's something to watch, particularly when using these herbicides, represented by this graphic or this picture that I've got here, where in this particular trial, this was at the 1 litre of dual rate, and it was really evident that there was pigweed in this situation emerging down the planting line because the herbicide had been stripped out of the furrow. In this particular trial, we also had 2 litres per hectare, which actually controlled, so had enough herbicide left in the furrow to control those pigweed germinations, but the combination of pulling the herbicide out and the lower rate in this situation gave escapes down the planting line. So that's something to watch out for. The other issue in this situation, by applying a herbicide and then stripping it out, particularly if we're leaving this open furrow, is we often will associate that with relatively shallow planting depth. And in that situation, if we get a big rainfall event, we'll move some of this treated herbicide down into the furrow. It will concentrate down there. We haven't got a lot of separation between the seed depth and the base of the furrow, and that's often associated with high levels of crop injury. If we adequately close the seed slot and we use some combination of press wheels, carrying harrows or chains, you can see that what we're trying to do here is we're trying to remove those furrows to stop that concentration of water and stabilising that herbicide by physically incorporating it in that situation. So generally speaking, the use of press wheels, covering harrows, etc. is recommended and is beneficial to managing some of the injury where the herbicide has been applied prior to the planter going through. One final slide as we move to wrapping up this webinar. Quite often get asked about carryover of Concep II treated seed. So we haven't planted it all this year. What can we do with seed as we move into following seasons? So it's relatively well understood that having Concep II on your sorghum seed can reduce seed vigor if the seed's left over time. We really don't have a good test to be able to test for seed vigor before we plant it, but we can do germination tests. And so if we rerun a germination test before we're ready to plant that seed, and the germination is still very high, that's probably indicative that the seed vigor, it probably hasn't been affected and is probably still robust. If the germination count has been substantially reduced, well then that's a potential red flag that we need to be concerned about. If we do have carryover seed and we're a little bit concerned about the quality of that carryover seed, I guess my first recommendation would be to try to find a paddock that we don't believe has grassweed problems, and therefore we're not going to be using metalachlor herbicide, and plant that seed into that environment and not use the metalachlor so the crop doesn't have to deal with it. However, if we are going to use metalachlor in combination with that carryover seed, then the best place to use it would be to target your heavier soil types. Make sure that we've got good soil temperature and moisture, so don't go too early with your planting window. Try to avoid those stresses that I mentioned before, especially waterlogging, and be conscious of your application rate. If we still need to use the high rate, it should be fine, but just be conscious that that will be the highest opportunity or the highest likelihood of causing some crop injury. And as I've also mentioned there, you really don't store Concep II treated seed for over 18 months. So if we don't use it this year, certainly make sure it's used the following season. So in summary, if we look at what factors increase the chance of injury and what reduce the chance of injury. So increasing the chance of injury, certainly rainfall or heavy irrigation between planting and emergence when we're wetting the soil down to the seed zone, and particularly if that's associated with waterlogging, that's often the primary additional factor which results in injury to sorghum when using metalachlor herbicides. Light soils are going to be more prone to showing up injury than heavy soils will be. Any stresses placed on that germinating seedling, which reduces its ability to metabolize the herbicide, is going to exacerbate injury. Obviously, using higher application rates is going to be more potential for injury than lower application rates. Marginal soil temperature at planting, obviously we're trying to get that seedling to establish and emerge as quick as possible and be able to detoxify that herbicide as quick as possible. And I mentioned a little bit about leaving planting furrows that are open. That's going to concentrate the rainfall, particularly over the top of the seed if the seed's planted shallow. So planting depth can also have an impact in there. On the flip side, what's going to reduce the chance of injury? Obviously using high quality seed and a mandatory application of Concep II to provide that seed safety will be required. We're not having seed that's carried over for a long period of time, so we want the concept only being applied within the last 18 months. Make sure we've got good planting slot closure and covering of that soil in that situation, and keep the excellent crop agronomy going, and the chance of having observable herbicide injury should be minimised. So at that point, I'd like to particularly thank Syngenta and Pacific Seeds for assisting in pulling together some of the information around metalachlor injury and the use of Concep, and a fact sheet that we have been developing on this topic as well, and Northern Grower Alliance for providing their data from some of their recent trial work as well, and acknowledge GRDC support for delivering this series of weed management webinars under the ICN 16 project. As far as further resources go, I just mentioned we are in the process of finalising a fact sheet on this topic. The draft is sitting on my desk at the moment, just looking for sign-off. So within the next few days, we will have that available to you in printed form. This webinar will also go up on the GRDC YouTube site, so we'll be able to come back to those sorts of references. There's also a hyperlink there to directions for mixing Concep II should you want to mix Concep II on farm as opposed to buying sorghum seed already with the Concep treated to it. So there's a link there to that reference on the Syngenta website.